Hello everyone. In this lecture, I am going to discuss potential energy curve. That is, I am considering an arbitrary shape of potential energy. So I am taking U along, that is the potential energy along y-axis, and position X along x-axis. And I am taking an arbitrary shape like this. Okay. So in this, I'm considering few points. Let me call it as this is A, this is point B, and this is point C, and this is point D, and this is point E, like this. I divided it into number of sectors because based on this region, I want to show you how the particle motion is influenced by this potential energy curve. So we know this. What is that? Conservative force Fc is equal to what you can write? Negative of minus du divided by dx. Every conservative force can be written as F is equal to du by dx, as I wrote it as x component only. So I am considering all x component of force. You need not to put the bar over here. So F is equal to minus du divided by dx, x component of conservative force. Okay, so what is this du by dx? Here du by dx is conservative force, but mathematically speaking, du by dx is nothing but slope of the curve. Am I right? At a given point. So if you start from A to B, all through these regions, if you plot a tangent at any arbitrary point, the direction of tangent is downwards. So in the region A to B, what's happening? For the region A to B, slope is negative. Slope M is negative. That implies, what is the slope? Du by dx is negative. Negative into negative, positive. So F is positive. Force is positive means, is it attractive force or repulsive force? Positive force means force is repulsive in nature. Nature of force is repulsive in the interval A to B. Next, I am considering the interval B to C. From B to C. So what is slope from B to C? If you consider a tangent at an arbitrary point like this. Okay, this is positive only because the angle subtended by it with x-axis is theta, which is less than 90 degrees. Slope is M is positive. So what does the slope du by dx? When it is positive, positive into negative is negative, because of which force is negative. That means from B to C, force acting on the particle is attractive. Force acting on the particle is attractive. And what's about B? I wanted to talk about a point like B and C. So if you plot a tangent either at B, that is like this. This is the tangent at B. This is the tangent at C. If you plot a tangent either at B or C, what's happening? This tangent is parallel to x-axis, because of which slope is 0. When slope is 0, du by dx is 0, then force acting on the particle is 0. Just now I told you in my previous lecture, what I said, when the resultant force acting on the particle is 0, what can we say? It corresponds to equilibrium position. So from this, what I can write, therefore point B and point C corresponds to what you call it as equilibrium. Not only B and C, at D and E also, D to E also, D to E. At B and C, force is 0, and all through the interval D to E, this is parallel to x-axis only. Resultant force acting on the body is 0, because of which these regions at B, body is in equilibrium, at C, body is in equilibrium. From D to E, body is in equilibrium only, because resultant force acting on the body is 0. This I wanted to show you mathematically. For a point like B, what's happening? Slope to the left and slope to the right that I am considering. That is force to the left region and force to the right region of this equilibrium position that I am calling it as R naught or X naught simply. X naught, about X naught. So I am considering a point like X1 and another point like X2. So when you move from X0 to X2, what's happening? The slope gradually keeps on increasing. The slope gradually keeps on increasing means force acting on the particle is increasing. But what is the nature of force in BC region? It is attractive. This I wanted to show you in a physical situation like this. So I am considering a spring to which a particle of mass m is attached. This is the natural length of the spring. It is neither stretched nor compressed. Equilibrium length. So this configuration I am taking it as x is equal to 0. Now from this x is equal to 0 position, I am moving the body slightly, displaced the body slightly to right direction through a point x2 up to a point x2. During this interval, as you keep on pulling the spring, what happens? Spring will keep on pulling you to backward direction. So the nature of force acting on this body about this point is attractive because it is attracting towards the mean position. So that's what it is showing B to C. So if you plot its corresponding potential energy, the shape will be like this only. Okay, so in the interval from x is equal to 0 to x2, the force acting on the body is to the left direction. I am applying the force to the right, but spring force is to the left direction. My force is not conservative force, so spring force is conservative. So in this interval, this is resembling the spring force. Am I right? Next, if you move it slightly from mean position to left position, somewhat like this, to this position, through a distance, let me call it as x1. So when you move it, as you keep on compressing the spring, what happens? Spring will apply a force to the right direction. Am I right? So in this interval, x is equal to 0 to x1, the nature of force is repulsive. Am I right? Nature of force is repulsive. So from left to right, the sign is negative, slope is negative, and right to left, that is in this interval, what's happening? Slope is positive. Therefore, change in the slope delta m is equal to final slope. Here the slope is positive, positive, minus. Here the slope is negative. So negative into negative is positive. Again, positive plus positive, altogether it is positive. Okay, that means what is change in what is slope here? Du divided by dx. So change in the slope means d by dx of du by dx, which is nothing but d square u divided by dx square, should be positive. When it is positive, what's happening? This point corresponds to what kind of equilibrium is this? Because body, if you pull it away from its equilibrium position and leaving, it is coming back. So because of which this configuration, this position corresponds to what kind of equilibrium is this? Stable equilibrium. Understood? So for stable equilibrium, through this, what are the conditions? Resultant force acting on the body is 0. That means du divided by dx is equal to 0. And at the same time, second derivative, d square u divided by dx square should be positive. When it is positive, have a look at over here. All through these values of potential energy. What is the point at which potential energy is minimum? If you look at this curve, simply we can say potential energy is minimum at B only. So this is also condition for minimum. Okay, so the point at which the potential energy is minimum, that point corresponds to stable equilibrium. And for minimum potential energy, du by dx should be 0 and d square u divided by dx square should be positive. And second situation I am going to consider here is about point C. I wanted to talk about point C. So have a look at this situation. So about point C, I am plotting two tangents. One is to the left, another one is to the right. So to the left, the slope is positive. To the right, the slope is negative. That means about C, if you take this point as a C point, if you keep on moving to the right, the slope is negative means force is positive. if you move to the left from point C, okay, the slope is positive, means force is negative. Force is negative, force is positive. So as you move away from the C to the right direction, force is positive, means body will not come back. Here, when you move to the right from the equilibrium position, the force acting on it is force acting, that is to the right direction. It is slope is positive, means force is negative. Here force is negative, because of which body is brought back to mean position. But here in this situation at C, for a point like C, what's happening? When the body is displaced from its equilibrium position, force is positive, because of which body will not come back. Or else if you displace it to the left direction, here if you displace it to the left direction, that is to the left direction, what's happening? Slope is negative, means force is positive. Because of this positive force, the body is force acting on the body is to the right direction, because of which body is brought back to mean position. But here, contrary to this situation, when the body is displaced to the left direction, slope is positive, means force is negative. Here the force is negative, means the force acting on the body is away from this equilibrium point C, because of which body will not come back to its original position or equilibrium position. That's why this point we call it as unstable equilibrium. Okay, about this point C, okay, slope is changing from positive to negative. Therefore, change in the slope, sign of the slope I am calculating. Change in the sign of the slope, delta m is equal to about C, just to the right and to the left. Final slope is downwards, negative minus of negative minus of. So this is positive. So positive means it is positive. Negative into positive is obviously negative. Negative plus negative is resultant, it is negative only. So change in the slope is negative. What is the slope? Slope is du by dx. So change in the slope is d square u divided by dx square. That implies d square u divided by dx square is negative. So for a point like C, okay, d square u divided by dx square should be negative, and of course it is at C point. Slope is 0, because it is parallel to the x-axis, because of which du by dx also should be 0. Okay, so if you look at this curve, what's happening? This is the local maximum about this point and this point. This C is the maxima. I'm not calling the total out of this total curve C is maxima. I'm calling this as a local maxima about C. This is maxima to the left and to the right regions. With respect to left and right regions, C is maximum, because of which I'm calling it as the local maxima. So for a local maxima, what should happen? D square u divided by dx square should be negative. Du by dx should be 0. Did you understand this? So for maxima, what is the condition? D square u divided by dx square should be negative, and du divided by dx should be equal to 0. So what is this maxima? This is here in this situation potential energy. So therefore the point corresponding to maximum potential energy is unstable equilibrium. The point corresponding to minimum potential energy is stable equilibrium. This is hard and fast rule, a thumb rule in all through mechanics or all through physics. The point corresponding to minimum potential energy is stable equilibrium. The point corresponding to maximum potential energy is called unstable equilibrium. So unstable equilibrium point, if you want to check whether it is stable or unstable, what you should do? First you should check du by dx is whether it is 0 or not. If at all it is 0, then only you can say whether it is when du by dx is 0, either it could be minimum or maximum. To decide whether it is maximum or minimum, you should go for secondary differentiation. Okay, secondary differentiation at C or at B, like that you should calculate. So if this is positive, then it corresponds to minimum. Minimum means it is stable equilibrium. If d square u by dx square is negative, it corresponds to maxima. Maxima means it is unstable equilibrium. What is about point like C to D to E? Any point between D to E. What's happening? du by dx is 0. There is nothing like d square, because there is no slope, there is no change in slope, because of which it is called neutral equilibrium. Okay, this is called neutral equilibrium. This is how we can talk about equilibrium based on potential energy curve.